Hmm. Shit, I actually like some video. Nice. Cool.
This is a lab. Measuring instrumentation, probes, sensors, gas and liquid chemicals, computers. Yeah, this is a lab, but maybe not the lab you would expect. Meet the NASA DC-8 Airborne Laboratory.
The airplane is designed for different instrumentation suites depending on the missions that we fly. So we have multiple zenith ports that look up, we have multiple nadir ports that look down, and of course many of the window blanks there.
There are 25 instruments on board the aircraft, not only from NASA, but from many universities and other government labs and organizations. And together, they paint a picture of the atmosphere that can allow us to completely evaluate what emission sources in the peninsula are contributing to poor air quality and how the chemistry actually works in terms of the outcome at the end of the day when ozone and particles are such a concern.
Yeah, this integration is about as big as we do, and if you've seen on board the airplane, you can see it's very full with all the racks and most of the windows, covered with the in situ probes that are there.
The Chorus AQ campaign will gather air quality data in and around the Korean Peninsula from multiple sources, such as ground stations and maritime sensors. However, the Chorus AQ aircraft will be the ones to provide the most detailed information over a larger geographical area and at different altitudes.
So in order to understand how it all works, we have several aircraft that we have to fly. One is the one I'm standing on right now, the NASA DC-8. The DC-8's role is to measure the atmosphere directly. From this aircraft, we can measure literally over 100 different compounds in the atmosphere.
The airplane flies as easily at 500 feet as it does at higher altitudes. That enables us to do both remote sensing, which is using radars or LiDARs, as well as we can fly lower, we can do vertical profiles with our in-situ sensors, which is currently what we got mostly on this airplane.
In order to understand the atmosphere, there are many different molecules that we have to measure. The satellite will not see all of them. And so by being able to measure what the satellite will see, and at the same time see all of the details, we can begin to understand what sources and what meteorologies and what combinations of conditions will affect what we see from space.
By combining detailed measurements from aircraft with those made by satellites, we can get a better picture of pollutants in our atmosphere.
So this aircraft carries instruments that work just like the satellite instruments. The higher we fly, the wider the patch of Earth we can see.
During the campaign, NASA King Air aircraft will mimic the measurements future satellites will make.
We fly at about 28,000 feet, and at that altitude we see about a 5-mile wide patch of ground. Like mowing the grass, we're just trying to cover a patch on the ground continuously and make a map of what the pollutant distribution looks like.
So we have a small King Air aircraft flying above all throughout the day, measuring the way the future satellite will measure air quality. Meanwhile, the DC-8 flies underneath, showing what the distribution of pollution is above the ground. That allows us to understand how to connect what the satellite sees with what's at ground level.
Chorus AQ has in its team 2 smaller aircraft equipped with atmospheric chemistry measuring instrumentation. A King Air from NASA Langley Research Center, and a King Air provided to the Korean National Institute for Environmental Research by Hanseo University.
The Hanseo King Air aircraft is relatively smaller than DC-8 in NASA. It can freely access source of pollution and measure air quality capital territory that cannot approach using DC-8.
Working all together, scientists from the Chorus AQ campaign will provide valuable data and test the technologies needed to better understand air quality and the flow of pollutants within our atmosphere.
We can only fly the planes for a very short period, but the details that you get from the aircraft help inform the observations from space and from the ground, and how models can interpret those observations.
From this mission, we'll have better models and better mission data for Asia, and so we'll be able to extend the usefulness of this well beyond South Korea to other developing cities around the world.
We have the tools to study our atmosphere. Now, let's go exploring. Get to work at 5 o'clock. Morning briefing at 6:30. It's just another day at the office. Or is it really?
There's a lot to juggle in the field, so life in the field can be quite hectic. It takes 3 hours to do a full warm-up of all the instruments on this aircraft. That means a start at 5 a.m. in the morning and a takeoff at about 8 a.m. The forecasters will look at the conditions to verify that the flight is ready to go, and the plane will take off for an 8-hour flight.
So, if you're a scientist studying air pollution, where should you be doing your research? Yep, that's right, in the air.
And once the plane takes off, the fun begins. There's a lot of talk on the headsets about what we're seeing and whether it makes sense in terms of what the models had predicted. Don't forget that this aircraft is flying in the atmosphere to verify whether the models can do a good job of predicting air quality. Each flight begins with a pass through the city of Seoul for a chance to see what that looks like. And then we go to high altitude to fly along the peninsula along a route that we've chosen and looking down with what we call the LiDAR. The lasers that point underneath the aircraft provide information on the pollution levels at different altitudes down toward the ground. And we have to use that information to decide where we will want to sample in altitude along that same path following the LiDAR paths. That 8-hour flight does not stop us from continuing forecasting on the ground and trying to give information to the flight as it happens in case conditions change. And so those days can be very busy between planning tomorrow's flight but making sure that today's flight happens well.
There's a lot to do on the flight days for the scientists on board the aircraft. However, there are other teams that also have to be working around the clock in order to have these airborne laboratories ready for investigating the atmosphere.
On this mission, the maintenance crew is pretty busy. We've got so many scientists on board. All the scientists have different needs and requirements, such as changing out some of the gases they have on the airplane. They also need to definitely make sure the airplane is pre-flight right, so we're good to go. Check out a lot of the systems. They're refueling the airplane. Before the flight, they take off all those covers off all the probes, which actually takes quite a while, quite a bit of time. And then after the flight, they need to put those back in place. So, I mean, the maintenance crews are the guys. They're the first guys to show up in the morning and the last guys to leave at the end of the day. They make sure we have a good jet for that day's mission. And if we break the jet on that mission, they're the ones who've got to fix it and get it ready for the next one.
Teamwork is the key to a successful campaign. The Chorus AQ mission involves the coordinated effort of over 500 people.
So we have about 505 people registered on the mission website, and of those, about 300 have been active participants at some point during the deployment, and we had to ensure that everybody had access when they needed.
Scientists, crew, technicians, but also equipment, supplies, logistics. A massive scientific research mission requires planning ahead and effective management.
Preparations for something of this size begin years in advance. And so, having already visited here with the Earth Science Project Office several times, we were able to put together a situation that would enable this many scientists and this many resources to be put into play.
ESPO was involved in all phases of the mission, from its conception to its planning and the implementation. We need to understand what the researchers want, which become our requirements, and then we come here and see how we can best meet those requirements, whether they are logistical or operational.
The Earth Science Project Office is in charge of managing the mission. Anything you need to accomplish your objectives during the mission, they are the people to go to.
Entering a foreign country is very difficult with all of the things that we bring. Operating in a foreign country is difficult because their airspace is very busy and maybe some of their procedures are different than ours. And keeping the flow of people and information and equipment smooth and in a way that does not interrupt or distract us from the science is a great talent, and we appreciate the Earth Science Project Office's support.
They are the ones making sure scientists have everything they need to keep working every day. So if you want to do a good job, you have to go to the right place and measure at the right time with the right people. And for these people, the right place is in the air. Although in the end, for them, maybe it wasn't just like another day at the office.
Yeah, it's a totally different experience.
The work we do here day to day is much different than what we do in the lab.
I've been waking up pretty early at about 4 a.m.
And then we get out here at about 5 to warm up our instrument because the laser takes a while to warm up to peak power. We'll be taking out gas cylinders and putting in new ones.
After every flight, we switch out the air canisters for the next day's flight.
Filling water or calibrating the instruments, making sure they're running correctly. And then we come back out and mess with the laser a little more.
So I've definitely developed some of my muscle mass here.
You know, it's a lot of work, but it's also a lot of fun, and definitely different from just working in a lab or in an office all the time.
For the first time in my life, I saw the horizon as a curved line. It was accentuated by a thin seam of dark blue light, the atmosphere. This was not the ocean of air I had been told it was. I was terrified by its fragile appearance. In 1983, German astronaut Ulf Merbold, on board NASA's space shuttle, was struck by how vulnerable the layer that protects us from outer space really was. He was right. Industrialization and economic growth have given us many commodities and technologies, but they have also generated a dangerous side effect: pollution.
Air pollution has a great impact on human health.
More than 7 million people die per year due to the effects of air quality.
It's a big problem. Populations are growing, and the impacts on health are an economic cost that I think governments are very interested in.
Understanding how we are affecting our atmosphere and the quality of the air we breathe is essential not just to continue developing our societies, but also to our health and therefore our survival. By combining measurements from satellites, ground stations, and aircraft over the South Korean peninsula, Chorus AQ will create the most complete picture of air quality ever measured.
As atmospheric chemists, we do know a lot about the basics of air quality, but the specifics of what happens in Korea are not something that we know a lot about.
It's not a mystery to us that there's a lot of air pollution. What we're really trying to do is learn how we can best help the South Koreans improve their air quality.
The government is trying to come up with a better strategy to fix this issue, but it's not that easy. You know, it's very complicated scientific issues we are facing. So I think this mission really helps us to understand what is going on in our country.
But air pollution is also an environmental problem common to other cities in many countries.
It turns out that there's many cities around the world that have similar problems to Seoul, even in the United States. And so this field study will help improve the models and the processes in the models that will benefit many other cities around the world.
The information gathered throughout the Chorus AQ campaign will help us improve our models of air quality and better understand the flow and interaction of pollutants in our atmosphere.
Almost anyone who you tell about the Chorus AQ experiment will immediately ask about how much of it's coming from China. Transboundary pollution is always a concern, and we came here to look at that as well. But we've had the good fortune of having a weather condition that has created a lot of stagnation in the Korean country and has prevented Chinese emissions from having a large impact on Korea.
Yeah, we sort of expected that frequently there would be pollution from China blowing over Korea. But due to the meteorological conditions this year, that didn't seem to happen very much.
It turns out on some days the emissions from China is impacting South Korea, but on many days that we're here, it's entirely due to the pollution emitted by the 51 million people living in South Korea.
And what we believe is that this will motivate the Koreans to understand that they can make a difference in their own air quality by making local changes of things that they can control rather than worrying only about what's coming from outside.
Having detailed information on the sources causing air pollution is one of the most important outcomes of an air quality study. Decisions can be made in order to address environmental issues on a region.
We have also seen that the position of some emission sources, in particular with Seoul being in the northwest corner of the country, and also many of the power plants and chemical facilities upwind of the city, that the location of some sources is potentially creating a bigger problem in Seoul than is necessary. So looking at the balance of where activities are located in Korea is likely going to be a topic of interest for the outcomes from course.
Real-time measurements of emissions over the Korean Peninsula has already proven the importance of this field study. Further and more detailed analysis of the data collected during the campaign will help scientists improve air quality models.
So now we will have the 6 weeks of data of hundreds of different compounds to evaluate our models with, to see how they do during these 6 weeks. And then if we can make our models reproduce this period, reproduce all the observations we've made, then we can have confidence that it will work well next year or next fall.
These models also help us test how we can best reduce the air pollution by what if we cleaned up the cars, how much would that help? What if we cleaned up the power plants, how much would that lower air pollution? So these models are useful tools to look at different scenarios.
It's relatively simple to filter out or scrub emissions, but it's not inexpensive. So if you know which ones will have the largest impact, then you can target those and still have good economic productivity and protect your population.
Computer models can help assess air pollution problems and guide politicians in the decision-making process to lessen industrial impacts on the environment.
We definitely have technologies that will help us with air quality, but the economic factors always come into play. And so people are always looking for ways to do things more economically, but that doesn't always mean doing them cleanly. And so regulations are needed to make sure that we don't take shortcuts and that we make the proper investments in making sure that our activities are not having an undue impact on the environment.
After weeks of hard work and intense data collection, the Chorus AQ field study has enhanced our knowledge of our planet. Our understanding of the complex processes that take place in our atmosphere.
With Chorus AQ, we take another step toward the future of an air quality observing system that is going to make us able to be more effective in identifying where poor air quality is developing and how to better understand what's driving it.
What we've learned here can also be applied to other cities and hopefully can help us improve the air quality around the world.
Because I think the air pollution issues is not only for us, but also from some other countries.
We are paving the way to better understand pollution and our impact on air quality in our atmosphere. But there's still much work to do ahead of us.
Well, I think that as we reach 7 billion people on this planet, the consequences of what we do have a very significant impact on the environment, and we need to understand what we're doing very well.
So this is the first step of a long journey. We will still need additional aircraft measurements and ground-based measurements going forward.
We can't be everywhere with the plane. But now that we demonstrate here how the plane works in concert with satellite observations on the ground, we can use satellite observations to point the aircraft to the places where we can learn the most, or the places that are in most need of understanding what's going wrong.
So we must continue investigating, exploring this world to improve the lives of all of us who call this planet home.
When you put a human being in a spacesuit, suddenly the impossible is possible. Since 1965, NASA has conducted hundreds of EVAs, short for extravehicular activity.
So when I think of EVA, I think of the symbolism of a fellow human being existing for even just a short period of time, alone and separated from nearly everything else. And I think of that symbol of that single person representing our species and representing our voyage of exploration.
Before exploration can take place, before a human being can step outside the spacecraft, another mission must be accomplished: the creation of the spacesuit. Throughout the history of EVA, NASA has sought to build the best spacesuit and tools to match the job required for the mission. For our suit engineers, this means designing, testing, and redesigning to get it right. During Gemini, our designers were faced with a tough challenge to create the very first U.S. spacesuits. Suits that would allow astronauts. New suits were developed for the Apollo missions. This time, astronauts needed to walk on the moon while carrying their own life support on their backs. With planetary surface exploration as the objective, the suit had to bend and move to facilitate tool use and protect the human. During the shuttle years, NASA redefined what could be done with EVA suits and tools: retrieving broken satellites, rescuing and rebuilding the Hubble Space Telescope, and building the International Space Station. The same shuttle spacesuit is on the space station today. It allows us to maintain and repair our home in space. But what about future missions? What kind of a suit will we need? Will we be walking on a planetary surface? Floating in microgravity? Or both? NASA is already investigating the next generation of spacesuits, creating a variety of prototypes to prepare astronauts for the journeys ahead. The Z2 is one of those prototypes. Its sleek design looks different from any other spacesuit NASA previously built.
We were able to take some artistic license on this prototype spacesuit and have some fun with it and engage folks out around the country for what they would like to see in a spacesuit. We worked with Philadelphia University to do the initial layouts of the suit, and then we have some in-house fashion designers that also help build our spacesuits, and they were able to bring their experiences to it and evolve that cover layer to make it even better than what we started with.
The Z2 isn't just fashion forward on the outside. It's also technologically advanced on the inside. This is one suit made for walking, on other planets, that is.
To be a planetary spacesuit, some of the special features on the Z2 are boots specifically designed for walking and for keeping your foot integrated into the boot well, like a good hiking boot. It also has a lot of lower torso mobility that allows you to walk naturally so that you can go uphill, downhill, into craters, pick up a rock, as a geologist would want to do on a planetary surface.
Like any prototype, NASA hopes to learn a lot from the Z2 as it continues to improve and develop spacesuits.
Prototypes are really important for spacesuit development because you can only do so much in the modeling and analysis world. You really don't know how well the suit works until you integrate it with a person. You get the feedback that a person can give you. You have them walk around, you have them try different tasks. That's how we really know that we've done a good job designing a spacesuit.
Another suit in the works is the Prototype Exploration Suit, or PXS. This suit could be used for EVAs in microgravity, or it could be further modified for walking on planets. As with all future spacesuits, NASA is wanting to see better mobility, more visibility, and better control and communication.
So one of my main responsibilities on this spacesuit is the suit control assembly, and that's the box that sits right here on the front of the suit. And it allows the crew member to control their life support components, such as their cooling and their pressure, and it also controls a lot of the electronics, such as the radio and the volume, and they can see some of the data that's coming back and forth from the suit computer to that display. So one of the great things about this job is that after designing the box, I'm able to get into the suit, since it's one of the smaller sizes, and we can actually see what the limitations are, with my own hands and eyes, and not just hear that secondhand from another test subject that would be looking at the same data. And then to take that back and then to go build the next prototype and incorporate the changes that need to be made so that it works better the next time.
Whether it's the PXS or the Z2, new NASA spacesuits have a big job to do.
And that's not just being in a vacuum, but it's very hot, it can be very cold. And then in addition to that, there are little micrometeoroids that are flying past that you have to protect in case it does hit the suit. So there's a lot of things that go into protecting the crew member in addition to just being in a vacuum. And when we go farther to the moon or Mars, you have to protect in case you trip and fall. So there's a lot of protection that the suit has to take into account.
No matter where we go or what we do, spacesuits and EVA tasks will continue to change and evolve. To keep up, spacesuit engineers will use new technologies, new materials, and new ideas to help us on our way.
In the future, I'm looking forward to spacesuits that are much more of a tool for the astronaut, that is more integrated with the human, and is less of an encumbrance and more of a help.
I think of EVA as basically a ship of exploration, a ship of learning and understanding, both about what makes us individually human and about what makes us together a team that seeks to learn and understand what the truth around us is. And that search for knowledge, that search for truth is, I think, one of the most noble and meaningful endeavors that we can pursue together.
This is a story about heat. Heat in our atmosphere, our oceans, and land. When you think about it, events like droughts, hurricanes, and fires, all of those are just different ways we see heat expressed throughout the Earth system. You've probably been bombarded with a lot of intense headlines in 2020. Hottest temperature recorded here, largest wildfires there. It's been a lot to take in. My name is Leslie Ott, and I'm a research meteorologist at NASA's Goddard Space Flight Center. So the reality is the stage was set many years ago for these events. Over the last century, human activities have increased the concentration of greenhouse gases in our atmosphere. These gases act like a blanket, trapping heat and leading to overall warming of the planet. Many of these gases remain in the atmosphere for a long time, meaning that we'll be feeling the consequences of this trapped heat for many years to come. Which unfortunately means next year is probably going to bring a lot of the same kinds of stories that we saw in 2020. But taking a look at all the different ways our planet responds to the variations in movement of heat can help us better prepare for the future. Maybe one of the most obvious ways that we saw heat this year was through fire. I know the Australian bushfires were big news last January, and when you think about it, years of prolonged hot temperatures and drought really set the stage for these fires to be more likely and more severe. With drought and heat waves, we typically see an increase in the availability of dry fuels, which leads to more powerful fires. So when you have multiple years of intense heat, it's not surprising to have significant fire events like we saw in Australia. These fires were so extreme that we saw smoke injected as high as 18 miles above the surface. That's really important because when smoke is injected that high, it can have the same type of effect as a volcano, having these very, very broad impacts across whole hemispheres of the planet. At NASA, we use computer models like the Goddard Earth Observing System to help us study how aerosols and particulate matter move through the atmosphere. So we take these models, we input real-world observations and data to track fire emissions to help understand how they're forming, where they're going, and how much of an impact they'll have on you and me. In California, heat waves have increased fire risk, and as a result, we saw a lot of synchronized fire activity. That is, many dangerous wildfires burning at the same time. And unfortunately, these types of huge fire events are becoming more and more common across the western United States. And that's a big problem. This year, Siberia also had a remarkable and active fire season. What we saw was that temperatures in the region were much higher than normal for this time of year. In fact, the temperatures above the Arctic Circle broke records in many of the same regions where the fires were burning actively. In the Arctic and boreal forest ecosystems, heat waves can exacerbate fires. And in the Arctic, you also have to factor in permafrost, which is soil that's frozen for long periods of time, and that can make the impact of fires in high latitudes even more complex. When severe fires burn in areas with permafrost, we lose this important insulating organic soil layer, which accelerates thawing, and it's potentially releasing carbon that's been stored in the soil for hundreds and in some cases even thousands of years. And you sometimes see these zombie fires, which happen when wildfires burn deep into peatlands or smolder in forests under snowfall. If that temperature doesn't get cold enough to extinguish the fire, they can continue to burn over the winter, even long after the visible fire's been extinguished at the surface. So come spring, they reemerge and they continue to burn back on the surface again. Studying what happens in the Arctic is really important because it's warming about 3 times faster than the rest of the planet. And all those aerosols and the carbon that come out of the Arctic don't necessarily stay there. They affect the heating and air pollution in much larger regions of the planet. Another part of the planet affected by heat, of course, is ice. Land ice in the form of ice sheets and glaciers where we've seen significant melt in recent decades, and frozen ocean water, or sea ice. This year, the Arctic sea ice minimum almost reached a new record low. It was second only to 2012's extent, which was an anomalously low year in part due to unusual weather conditions. Sea ice shrinks and grows with the seasons. After reaching an annual minimum extent in September, Arctic sea ice begins to grow again as sea temperatures cool off for the winter. This year, Arctic sea ice had an unusually slow start to the regrowth period. In particular, the Laptev Sea, which is sometimes called a sea ice nursery because much of the Arctic sea ice initially forms there, was too warm for meaningful sea ice growth until much later in the season than usual. Oceans absorb heat from the sun, and our atmosphere prevents this heat from escaping back to space. The movement of this heat is one of the primary drivers of circulation and global weather patterns. We can measure the temperature of the ocean, and what we saw this year was unusually high surface temperatures across the Atlantic. The warm moisture that comes off the ocean acts as fuel to storms. So as this layer of the ocean gets even warmer, we're seeing that storms are becoming more and more intense over time. In fact, 2020 sea surface temperature contributed to an exceptional year in terms of Atlantic hurricanes. We saw 30 named storms, a new record, and 12 of these storms made landfall in the US. What's really interesting is that many of these storms intensified really rapidly. Not only are storms intensifying more quickly, but what we're seeing is that they're stalling near coastal regions more often, which is devastating in terms of floods and storm surge. While we're not 100% sure what is causing these storms to stall, it may have to do with climate patterns shifting in response to rising global temperatures. It's always really tough for a scientist to say any particular fire or any particular event was because of climate change. But But we're getting to a point where we're starting to see season after season of record-breaking wildfire, season after season of really intense storms, that it becomes much easier to understand that this is likely the result of long-term climate change. In general, more heat means more energy in the Earth's system. So while 2020 was a significant year, it's important to know that this probably wasn't an anomaly of a year. We're likely to experience many similar years as the Earth's climate gets warmer. So while we see emissions from cars and airplanes, but we know that human activities have a powerful impact on our environment. Long-term strategies to curb human-induced climate change would have to focus on implementing cleaner technologies so we can reduce emissions without affecting people's daily lives. So while this is a story about heat, this is also a story about connections. Nothing on our planet happens in a vacuum, and our actions today impact our tomorrow. The choices we make now can make the difference between continued increases in greenhouse gas emissions and 2020 being the year that they peaked.
Preparing a small satellite to conduct some big science, an update on our upcoming mission to a metal-rich asteroid, and a new director for the International Space Station. A few of the stories to tell you about this week at NASA. Our Ames Research Center in California is in the final stages of pre-flight preparations of BioSentinel. The CubeSat is one of several secondary payloads targeted for launch on the uncrewed Artemis 1 mission to the Moon with our Space Launch System rocket and Orion spacecraft. BioSentinel will eventually fly past the Moon and into orbit around the Sun to conduct a 6-month investigation on the effects of deep space radiation on yeast, a living organism. This will be the first long-duration biology experiment in deep space and could help us better understand the radiation risks to humans during long-duration deep space missions. The Solar Electric Propulsion, or SEP chassis for our Psyche spacecraft has been delivered to our Jet Propulsion Laboratory in Southern California, where the mission's assembly, test, and launch operations phase is underway. The SEP chassis, built by Maxar Technologies, is the main body of the spacecraft that includes the 6.5-foot wide high-gain antenna and the frame that will hold the mission's science instruments. Targeted for launch in August 2022, the Psyche mission will explore a metal-rich asteroid of the same name located in the main asteroid belt between Mars and Jupiter. Studying the asteroid, which may be the core of an early planet, could provide valuable insight into how Earth and other planets formed. More information about the mission is available at nasa.gov/Psyche. NASA has named Robin Gatens as director of the International Space Station for the agency. She was appointed to the position after serving as the acting space station director for about 7 months. Gatens has 35 years of experience at NASA in both the space station program and in development and management of the life support systems for human spaceflight missions. As space station director, she will continue to lead strategy, policy, integration, and stakeholder engagement for the space station program at the agency level, while working closely with officials at our Johnson Space Center in Houston. According to NASA-supported research, the 2021 Arctic wintertime sea ice extent reached on March 21st tied 2007 as the 7th smallest extent of winter sea ice in the satellite record. This year's maximum extent is 340,000 square miles below the 1981 to 2010 average maximum. For perspective, that is equivalent to a missing area of ice larger than the states of Texas and Florida combined. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/Tuan.
NO1E6, NO1E6, Juliet Oscar November calling. NO1E6, NO1E6, Juliet Oscar November calling. NO1E6, it is 6 Juliet Oscar November. You copy me, Chris?
Copy you loud and clear.
Okay, I'm going to patch them through. Please, 1 minute.
This is Owen. How has seeing Earth from its orbit affected you, in your frame of reference when moving around the ISS, or in your perspective of humanity as a whole? Over.
Hi, Owen. That's a great question. Seeing Earth from up here, it's a beautiful thing. It's just this peaceful place with no borders there, and you just see this wonderful colors of blues and greens and browns and white clouds and snow-capped mountains. And it really gives you an appreciation for Earth as a spaceship for 7 billion people, just like our spaceship is keeping us alive, and how we need to take care of Earth because it takes care of us. Over.
This is Spencer. What happens if you vomit in the space station? How do you clean it up? Over.
Well, hi, Spencer. Fortunately, we are prepared for vomiting in space, and we bring special bags that if we're feeling the urge to go, we use these bags. Occasionally, on the launch, it can surprise you, and but we have bags in the launch vehicle as well. If you didn't make it in the bag, it would be a real mess, and it would go everywhere. It would take quite a bit of time to clean up. Over.
This is Lucas. How has the COVID-19 pandemic affected you while you're in space? Over.
Hi, Lucas. The pandemic has affected us because it's affecting our families. Our daily life here on the space station is largely the same with or without the pandemic. We are safe and we are executing our job and keeping the space station running and functioning and keeping ourselves healthy with our daily routine. But we're concerned for our friends and family and loved ones because they're in Russia and in the United States having to deal with it just like you are. Over.
This is Allie. What will be your first meal when you get back to Earth? Over.
Hi, Allie. I like to eat, and so I'm looking forward to any food that somebody makes. But one thing we don't have is an oven here, so something that comes out of the oven and you smell those smells and you eat a nice hot meal, that sounds terrific to me. Over.
This is Sawyer. What does it feel like when the rocket lifts off? Over.
Sawyer, when the rocket lifts off, it's this tremendous feeling like somebody's pushing you in your back and shoving you faster and faster and higher into the sky. And there's a few periods of time where our engines change, called staging, and there's some bumpiness and a little bit of shaking in the spacecraft during those periods. But the rest of the 9 minutes is just like a giant force is throwing you into the sky. Over.
This is Jordan. What does the space station smell like? Over.
Jordan, the space station has not too different smells than you'd have in a home down there. We try to keep ourselves clean. We try to keep the space station clean. In fact, tomorrow is Saturday, and that's our cleaning day, and we do our best to keep it neat and tidy. But occasionally there's smells where we have to change fluid. A lot of times that has to do with our bodily functions in the toilet, and they can be smelly there. But for the most part, the space station, to me, it smells just like a normal home. Over.
This is Eric. Was training to be an astronaut harder or easier than training to be a Navy SEAL? Over.
Well, Eric, they were totally different. The training to be a Navy SEAL initially was very hard for 6 months. Training to be an astronaut or a cosmonaut is a long process, and it takes many years of hard work. So, and it's more academic, more having to do with your brain. In SEAL training, we had some academics, but largely it was a physical thing. So 2 entirely different programs. Over.
This is Owen. What experiment that you don't have the most unexpected results? What was the expected and
Yeah, and we're like,
Wait.
what?
Wait.
So you're my sister's sister. He's like, yeah, you're my sister's sister.
Yeah, that's why it's needed. You just have to, you really have to say it's a small world.
For real. It's so trippy how like I know like all these different people from like yeah. What is this?
Guru shots. It's like they challenge yourself to taking photos. So like I already reached the elite level. Yeah.
Oh. That's pretty fucking cool. It's like a challenge.
Yeah. But it did. Got a few likes. Already got 3,000 points. Likes, how many likes? People have liked this photo already, like a bunch of these photos. I got 2 likes on this one. This is some modern day.
So we got there. So I got there at 4 o'clock, eh? And like Bruce, he like totally forgot that we were starting at 4 and not at 5. So he just before 5. Her brains. He used to want to like cut the day short on like Friday, and then added an hour. And adds an hour to each of the day this week, and he shows up fucking late.
I've seen Bruce. I follow Bruce around when he meets his kids. I don't mean that. I mean that like, yeah, I know Bruce.
Yeah.
It's just like on a personal level, fuck man, he needs somebody that's like a butler, like a personal assistant to him. You know what I'm saying?
Yeah.
Like, fuck, Bruce, you really need to get going. You're late, and you're the one. And then, and then he's just like, what are you doing? He walks really slow too.
Yeah.
So, shit, bro. I can only imagine how long it takes him to get to. He must be like me, you know, he's like checking his pockets, being like, okay, have I got my camera, have I got batteries, have I got this, have I got my gloves, have I got my mask, you know. Must be that way.
There's this new girl who just joined the team. She's the understudy for this other part because this other actor hasn't been showing up. And then, yeah, so. And we happen to be in COB the same year, so it was just some random person there. Yeah. And she's the one
like the stuttering, the hesitation,
Yeah.
and a lot of the pausing.
Yeah.
Yeah, like there's natural rhythm, there's natural this and that, but like as you said, the beat.
Yeah, I used to go with my first monologue. I have to like up and around the stage.
Yeah.
And then they were pretty impressed. They were like, wow, Vanessa.
Wow, Vanessa and Adele and the Doctor. Pretty much.
Yeah.
Yeah. Were you mimicking me when you're doing those lines?
Huh?
Did you ever do the Doctor lines? Cool, I'm on YouTube, bro. Sir? Sounds like something going wrong. It's pretty cool. It's got a whole hub. Just entertaining hub, just until that. James, how do you feel like everything's going?
I feel like everything's like starts to come together now.
do a lot of Zoom calls, and I look like this. Did I look okay? Was I getting some notes correct?
Yeah.
Like, I was just like thinking, I was just like looking at the music video, I was like, I think I lost it. For real, I got it. Cool. Cool. Holy shit, I actually did something. You can change it.
What?
You can change it.
What? The song?
Yeah. I'll change it actually.
Like I'm playing to my playlist.
Is this your playlist?
Yeah.
Meh.
The song's not even that long. You're still wearing your shoes.
Yeah, because like good socks keep getting holes in them.
Oh.
Because of all the nails.
Yeah. Like all the splitters and shit.
Yeah. Why would you carry that activity by yourself? Like, you're doing well.
Yeah, I was like, and then I'm like, on top of that, you have 3 kids that you're taking care of, but you're good, man. Like, that made me feel better, thanks. take care of themselves through the day, right? So it's like, I got 10.
Stop. Isn't that creepy? I have enough time for that.
Every time I've done my scene, I go to the side. I had to tell the old people who was like, who was done. I was like, because I know my lines, I just need just an extra second for me to like remember them, and then like put them. And Bruce, there were every time like not even like half a second was like where they're like the what's this word you know.
Yeah, like without missing a beat, they would just correct you.
Yeah, and then like I was just like you know what? But it would be great if you guys
Just like
wait
just give a second, like
yeah.
I'm not as receptive or as like as quick or as like as choppy as y'all.
Yeah.
Just give me that little bit of a second, just pause like I do.
I was like let me at least have 5 seconds, and if I need help, I'll say a line, okay? And they're like, okay.
Yeah, because like they're not in control, like they're not puppet masters.
Yeah.
Like you need time to yourself. You need to say it simpler. Exactly. You say it to the scriptwriter. Like, did you like? Is there any way we can say this simpler? Because like I'm fumbling over the words no matter how many times I fucking practice.
Yeah. And I'm just like, and they're like, okay. And then they let me do that while I was performing. And there's probably 2 times where I asked for my line. And then and it totally fit with like how I was presented it, the way how I was then. And then they're like, wow, this is actually pretty good. Because I went up there with like, script that out and just like, jumped like lines like that.
Yeah. Put effort into your lines. This is the same premise as fucking the Halle Berry movie, Catwoman. She dies from falling, and then she gets woken up by cats licking her face. This is to that same premise. And I would know because I watch all these superhero movies.
Yeah.
And this is like some sort of like, there's like a lot of movie influences in this one since the last time that I've seen it. It's like, I've been wondering, okay, like there's a lot of like Alice in Wonderland influences in other music videos that you have seen. But then this one, this takes the cake because like I remember which influences it's taking from. There's Pulp Fiction, and there's like the one I just mentioned, and like Basic Instinct. Oh my god, like this is pretty good. Pretty good.
This is Sunbeam, the one who sings Disco. So if you see like a lot of like those like heavy movie influences, it's most likely JYP.
Okay, alright.
Yeah, because she works for him, right?
That's true.
Yeah.
And like, you want to get like the most creative influence, you have to like have somebody who's also creative. Because like, look at this. You need to have as many girls like that to like, wow. Okay, yeah, I get it. I really do get it. See Pulp Fiction. No, but like Reservoir Dogs, when they have their like bow ties untucked and they're just all like hanging around there. Yeah. Every time I look at it, I'm just like, movie influence. God damn. Ugh. Ugh. I might be getting a pornography artist to do a lewd drawing of me. I don't know. There's a lot of people I'm networking with right now on Discord. I might be a nude artist. I might be a nude model. I don't know. Anyway, you want to get done? Yes, I'm wearing my shoes because like I don't want my... There's so many fucking nails across here. Like, I keep, like, every time I was watching here and like, I'm like, my foot's stuck. Like, for one of these fucking things. One of these ones. You know what I'm saying? So, like, is that even worth it to wear, like...
No, it's just like... thank you, like, you know, like, it's been ruining my socks. I'm like, yeah, like, same here, but, like, my socks don't get as ruined as yours because, like, you know, I'm gone most of the days.
Yeah, and I'm just like usually here, like, mom.
Yeah, by yourself.
Yeah.
Like that, like,
Yeah,
you
because,
know?
like, all my classes are online.
Yeah. So I'm just like, yeah.
Just like, fuck, I'm just all like, god damn it, there's so much fucking nail holes around here. You know what I'm saying? Well, how do you feel?
I feel better.
Buzz. Okay, more buzz. Pretty good. You good, kind of, or you want more buzz, kind of? Okay. Well, I'll go for a walk then. We looked okay. Like yesterday, I found out that like in the shadow, I looked like I was just all like. So I was just, you know.
Yeah.
Did I look that way when I left? Honestly. Did I look bundled? Like bundled, like.
Bundle as in, like, you're about to pick somebody up.
Yeah, cause like there's like these people being all like, hold on, like this. Hold on. How are they walking? How are they walking? How are they walking? How are they walking? They were walking like this. And then like this guy walks across the street and I'm just all like the only sign I give when I'm like I know somebody's there is like I do this heaven. Like when you're about to fight somebody, you don't move your head. You know, like I'm just like I usually like okay, like say I'm from this point, I'm like locked onto you, like I'm just like walking, like my head is like I'm not moving my head, like I'm just like looking directly at you. I'm just zoning in as I move in closer, basically. So like every time that I walk on the streets, it's like people going like to like walk across the street, and like by the time I get there, I'm still like, you know, I'm just like trying to look like as mean as I could, you know what I'm saying? You want sport bus? Okay. I got a little bit of paid money from Okay, I'm gonna end my stream here.